In this video, we're going to do the practice problems within the neutralization notes. So let's start off with example 1. We have to predict the products formed by sulfuric acid and calcium hydroxide reacting together. And we already have one of the products given to us, calcium sulfate. So firstly, recognize you have a neutralization reaction because you have an acid reacting with a base. I know this is a base because it contains hydroxide. We already have the salt given to us over here. We have the salt because that's the ionic compound. The other product must be the water. Must be the water. So now what we're going to do is we're going to go and predict B and C, complete those. And then when we're done completing those, we'll convert them to balanced equations. So hydrobromic acid reacting with sodium hydroxide produces water, and then we have to find out what the salt is. So hydrobromic acid we know contains bromine, and then the metal in the base is sodium. So it's going to be sodium bromide. That's a salt that's made. Okay, so next in C, we have the products, water and sodium chloride. So we have the salt. We have the base, sodium hydroxide. So we need to figure out what the acid is. We know the sodium came from the base here. So the acid must have been an acid that contained chloride. The acid that contains chloride is hydrochloric acid. So if we want to do these as balanced equations, hydrochloric acid from our naming rules and our formula rules is HClAq plus sodium hydroxide, once again from our rules where we learned how to write formulas for acids and bases, is NaOHAQ. Then we have water. I'm going to write it as HOH just to make my balancing a little bit easier, but you can just write it as H2O if you'd like, plus sodium chloride, crisscross between sodium and chlorine, AQ. It looks like if I count everything's already balanced, so we're good. Okay, next let's try the sulfuric acid calcium hydroxide example. I'll do it up here. So sulfuric acid, based on our rules for acids and bases, is H2SO4 AQ. Calcium hydroxide is CaOH2 AQ. Produces water, so HOH, liquid, plus calcium sulfate, CaSO4. So we can tell we're not balanced because we have 2 hydroxides and 2 hydrogens. So we only have 1 and 1 here. We can put a 2 here, and that makes 2 of everything. And it looks like we're balanced now. We have 2 hydrogens on both sides, 2 hydroxides on both sides, 1 calcium, and 1 sulfate on both sides. Now we're balanced. Next, we'll finish off with the hydrobromic acid and sodium hydroxide. So hydrobromic acid is HBr plus sodium hydroxide. That's from our crisscross rules. Produces water, HOH, or just H2O liquid if you like, plus the crisscross between sodium and bromide, NaBr. That's aqueous because it's a salt. Forgot aqueous up here. And it looks like this is already balanced. So in this example, or these examples here, we just predicted what the missing product or reactants was or were, and then we converted the word equations to balanced equations. Let's do example number 2. Write a word, skeleton, and balanced equation for the reaction between aluminum hydroxide and sulfuric acid. So we know that this is going to be a neutralization reaction because we have a base reacting with an acid. So sulfuric acid plus aluminum hydroxide will react in a neutralization reaction to produce. And now if you're not sure the products yet, you can actually write out the formulas first, and that might help you out a bit more. So sulfuric acid from our formula rules for acids is H2SO4 AQ Aluminum hydroxide from our crisscross and base rules is AlOH3 AQ. We'll put our arrows. And you can tell it's basically a double displacement. The H goes where the Al was, the Al goes where the H was. And so we get crisscross between aluminum and sulfate, which is Al2 SO4 3AQ. And the remaining product must be H2O, liquid. So what do we get here? We got aluminum sulfate as our salt. Plus water. No need to write dihydrogen monoxide. Water is such a common chemical, we just call it by its common name. So we're almost done. We did the word equation and the skeleton equation. We just need to write a balance equation now. So I'm going to rewrite this equation here and then just balance it. So H2SO4 AQ plus Al OH3 AQ produce Al2 SO4 3 AQ plus, instead of writing H2O, I'm going to write HOH just because it makes balancing a little bit easier. Let's see. So I have 3 OHs and 2 Hs. I have one aluminum only, and here I have 2. So what I'm going to do is I'm going to put a 2 here. That makes 2 aluminums and 6 hydroxides. So I'll put a 6 here because that will make 6 hydroxides. But then it makes 6 Hs. And so to get 6 Hs, I have to put a 3 here. That's 6 Hs, but now 3 sulfates, but that works. So they already have 3 sulfates here. So 3, 2, 1, and 6 seem to be the balanced equation for this particular reaction. And again, you need to practice this stuff until you understand it. So if you didn't get it the first time, go take a look to see if you can understand my final solution. That's the first step, and then try to get there yourself. Okay, so there is a balanced equation for aluminum hydroxide reacting with sulfuric acid. In the next video, we're going to take a look at some practical applications of neutralization reactions. In other words, when I say practical applications, that means where do we use these things in the real world? We don't just use these in a beaker or test tube in the lab. We actually use these things in the real world. So practical application of anything means in the real world, where do we use this stuff? And that's what we're going to talk about in the next video.